Hello, everyone. Welcome to Sleep Space. Tonight, we will talk about one of the most fascinating and mysterious questions of all time. Could consciousness exist without a brain? This question lies at the very heart of what it means to be alive, to be human, and to wonder about the nature of reality itself. It invites us to explore where our sense of self comes from, how it relates to the physical body, and whether it is bound by the brain or able to exist independently. This is not only a scientific question, but also a philosophical and deeply personal one. As you listen tonight, I invite you to reflect, imagine, and let your curiosity carry you. To begin, let's consider what we mean when we say consciousness. At its most basic level, consciousness refers to awareness, the ability to experience the world and yourself. It is the feeling of being alive, the inner landscape of thoughts, memories, emotions, and sensations. Imagine tasting chocolate, feeling sadness, or watching a sunset. These are not just mechanical processes, they are lived experiences. Consciousness is that quality of subjectivity, the first person perspective, the I behind your thoughts. It may sound simple, but understanding what consciousness is and how it arises is one of the greatest mysteries of science and philosophy. From the standpoint of modern neuroscience, the dominant view is that consciousness emerges from the activity of the brain. Your brain contains about 86 billion neurons, each connected to thousands of others through intricate networks. Electrical signal fire constantly, chemical messengers flow across synapses, and patterns of activity form. According to this view, consciousness is the result of these processes. Damage one part of the brain, and consciousness changes. Take anesthesia, and consciousness shuts off. Stimulate a region, and a thought or sensation may appear. It is a compelling argument for the brain being the generator of conscious experience. Yet, as persuasive as this is, there's still a problem. You can map out every neuron, describe every chemical, and track every electrical impulse, and still it doesn't explain why there is an inner world at all. Why does brain activity feel like something from the inside? Why isn't it just a machine processing data without awareness? This is what philosopher David Chalmers called the hard problem of consciousness. The easy problems, like explaining memory or perception, deal with functions. The hard problem asks why there is anything it feels like to be alive. Why isn't the brain just dark inside? Why is there an observer? This gap between mechanism and experience leaves room for big questions. If we cannot fully explain how the brain produces consciousness, perhaps consciousness is not something the brain produces at all. Perhaps it is something more fundamental, something the brain interacts with rather than creates. This possibility opens the door to the question of whether consciousness could exist without a brain. Looking back through history, many cultures and traditions assumed that consciousness is independent of the body. In ancient Hindu philosophy, the idea of Atman describes an eternal self, pure awareness that exists beyond the body and mind. In Buddhism, consciousness is often portrayed as a stream, flowing from one moment to the next, not tied to a permanent self or physical form. Ancient Egyptian thought emphasized the Ba, a spiritual essence that survives death. Plato argued that the soul is immortal and pre-exists the body, carrying knowledge from before birth. And in countless spiritual traditions around the world, consciousness is seen as something that continues after the body ceases to function. These ancient perspectives may sound mystical, but they illustrate that humans have long intuited consciousness as something more than the sum of brain activity. And now, modern science is starting to encounter puzzles that echo these old intuitions. Take near-death experiences, often abbreviated as NDES. Thousands of people who have been clinically dead, no heartbeat, little to no measurable brain activity, report strikingly vivid experiences. They describe floating above their body, watching doctors work, moving through tunnels, encountering beings of light, or reliving moments of their life in incredible detail. In some documented cases, patients accurately describe details of their surroundings or procedures that they could not have seen from their physical position. If the brain was offline, where did these experiences come from? Skeptics argue they are hallucinations caused by the brain shutting down, but timing is a major issue. Some reports occur when brain scans show flat activity. If consciousness truly shuts off when the brain does, how could people describe such rich experiences? Another phenomenon is terminal lucidity. This occurs in people who have suffered from severe dementia, brain damage, or neurological decline, sometimes for years. In their final hours or days, they suddenly regain clarity and coherence. They may recognize loved ones, speak fluently, or reflect with insight. From a strict brain-based view, this shouldn't be possible. Their neural networks are too damaged. Yet it happens often enough that it has been documented across cultures and centuries. Some researchers explain it as a last burst of brain activity, but others see it as evidence that consciousness can exist beyond the brain's limitations, only temporarily revealed as the body nears death. We can also consider extraordinary medical cases. There are individuals with hydrocephalus, a condition in which fluid fills the brain's cavities, compressing brain tissue. In some extreme cases, people have been found to have only a fraction of normal brain volume, yet they function in daily life, hold jobs, and even excel academically. One famous case involved a man who had only 10% of his brain tissue, yet lived normally and worked as a civil servant. These cases challenge the assumption that more brain tissue automatically equals more consciousness. Could it be that the brain is more like a receiver or a filter, and consciousness itself is more fundamental? This brings us to one of the most intriguing theories: the brain as a receiver of consciousness rather than its producer. Imagine a radio. The music you hear comes through the radio, but the music itself is not created inside it. It is broadcast through signals that exist independently. The radio tunes in, translates, and plays the sound. If the radio is damaged, the music may be distorted, but the broadcast still exists. Some philosophers and scientists propose that the brain might work the same way. Consciousness could be a universal field or property, and the brain simply tunes into it. If the brain is damaged, awareness may appear altered, but the field remains. Destroy the radio, and the music still plays. It just can't be heard through that device. This is a radical departure from mainstream neuroscience, but it offers a way to explain strange cases like NDES and terminal lucidity. Even modern physics gives us reasons to consider this. Some researchers, like Roger Penrose and Stuart Hameroff, have proposed that consciousness may emerge from quantum processes within the microtubules of neurons. Their theory suggests that consciousness could be tied to fundamental quantum phenomena, which exist beyond the classical brain. If so, consciousness might not be locked inside the skull, but rather embedded in the very structure of reality itself. While highly speculative, this idea resonates with a growing number of philosophers who suggest that consciousness could be as fundamental as space, time, and energy. This view aligns with a philosophy called Panpsychism. Panpsychism argues that consciousness is not something rare or emergent, but rather a basic property of the universe. Just as particles have mass or charge, perhaps they also have a rudimentary form of experience. If true, then everything in the universe, from atoms to stars, participates in consciousness in some way. Human brains would not create consciousness, but would instead organize and reflect it in complex ways. This perspective, once dismissed as mystical, is now being seriously discussed by scientists and philosophers searching for new frameworks to address the hard problem. Still, many scientists remain firmly grounded in the brain-based explanation. They point out that damage to specific brain areas consistently alters consciousness in predictable ways. They note that drugs, trauma, and diseases impact awareness. From this view, consciousness depends entirely on the brain. Phenomena like NDES and terminal lucidity, they argue, may be explainable with more precise brain science in the future. They see panpsychism and quantum theories as fascinating but unnecessary leaps beyond what the evidence supports. Where does this leave us? Somewhere in the middle of a grand mystery. We know the brain and consciousness are intimately linked, but we do not yet know if the brain produces consciousness or simply interacts with it. The possibility that consciousness could exist without a brain challenges our assumptions about life, death, and the universe. If it's true, it might mean that our awareness is not limited to our physical bodies, and that death may not be the end of experience. If it's not true, it still highlights the extraordinary capacity of the human brain to create the rich inner lives we all experience. As we continue our journey tonight, I encourage you to hold this question gently, with both skepticism and wonder. Could consciousness be no more than neurons firing? Or could it be something vast and universal, temporarily experienced through the filter of your brain? As you reflect on this, you might find your own perspective shifting, expanding, or deepening. And that is the real beauty of exploring a mystery like this. To understand whether consciousness could exist without a brain, we need to first explore how consciousness works when there is a brain. Neuroscience provides remarkable insights into how different brain structures contribute to awareness, memory, perception, and identity. By mapping out these systems, scientists have shown how intimately connected consciousness is to neural activity. Yet, as we will see, even the most detailed maps raise questions they cannot fully answer. Let's start with the cerebral cortex, the outermost layer of the brain. This wrinkled sheet of neural tissue, only a few millimeters thick, plays a crucial role in conscious experience. Different regions of the cortex specialize in different aspects of awareness. The occipital lobe at the back processes visual input, transforming raw light signals into vivid images. The temporal lobes contribute to memory, sound perception, and the recognition of faces. The parietal lobes integrate sensory information, creating a sense of spatial awareness and body position. And the frontal lobes, especially the prefrontal cortex, are central to decision-making, self-reflection, and planning. Together, these regions orchestrate the symphony of consciousness, turning sensory input and memory into the seamless flow of experience. Consider vision as an example. When light enters your eyes, it stimulates cells in the retina, which send electrical signals through the optic nerves. These signals travel to the occipital cortex, where they are processed and refined. But vision is not just about seeing light and shapes. The brain interprets those signals, linking them to memory and meaning. That's why you recognize your friend's face instantly, even in a crowd. Conscious perception is not raw input, it is constructed by the brain. The brain's construction of consciousness becomes even clearer when things go wrong. Damage to specific areas of the brain can lead to striking changes in awareness. A condition called hemispatial neglect, caused by damage to the right parietal lobe, leads patients to ignore half of their visual field. They may eat only the food on the right side of their plate, shave only one side of their face, or even deny that the left side of the world exists. Their eyes still work, but their conscious awareness does not register the missing half. This shows how consciousness depends not only on sensory organs, but on how the brain organizes perception. Another example is prosopagnosia, or face blindness, often caused by damage to a region of the temporal lobe. People with this condition can see faces clearly but cannot recognize them. Even the faces of family members or close friends appear unfamiliar, yet they may still react unconsciously to familiar people, showing changes in skin conductance or heart rate. This demonstrates that conscious recognition and unconscious processing can diverge, both rooted in brain function. Language offers another window into consciousness. The left hemisphere contains Broca's area and Wernicke's area, critical for speech production and comprehension. Damage to these regions leads to aphasia, impairing the ability to speak or understand language. Without these neural structures, the rich inner world of verbal thought collapses into fragments. This again suggests that consciousness, at least in its linguistic form, relies heavily on the physical brain. Neuroscience also reveals that consciousness is not all or nothing, but a spectrum. States of consciousness can be altered by drugs, injury, or electrical stimulation. General anesthesia, for example, reliably switches consciousness off. Patients may wake up with no memory of time passing, as though their awareness was suspended. Researchers have shown that anesthesia disrupts communication between brain regions, particularly the integration of information across the cortex and thalamus. When these networks can no longer coordinate, the unified experience of consciousness disappears. Sleep provides another natural example. During deep sleep, the brain shows slow, synchronized waves of activity, and conscious awareness fades. During REM sleep, by contrast, brain activity resembles wakefulness and vivid dreams appear. This suggests that consciousness requires specific patterns of connectivity, not just raw activity. The brain must weave signals into a coherent tapestry for awareness to emerge. One of the most compelling theories to explain this is called the global workspace theory. Proposed by Bernard Baars and expanded by neuroscientists like Stanislas Dehaene, it suggests that consciousness arises when information is broadcast widely across the brain's networks, entering a global workspace. Unconscious processes remain local, while conscious information is integrated and shared. This theory explains why you can drive a familiar route almost unconsciously, but when something unusual happens, a sudden stop, a flashing light, it enters awareness and demands attention. Consciousness, in this view, is the brain's spotlight, illuminating what matters most. Another leading explanation is the integrated information theory, developed by Giulio Tononi. This theory argues that consciousness corresponds to the capacity of a system to integrate information. The more interconnected and unified the processing, the richer the conscious experience. According to this framework, the brain's complex networks generate a high degree of integration, making human consciousness especially rich. Some proponents even suggest that any system with integrated information, biological or artificial, has some degree of consciousness, though perhaps very minimal. Experiments support these ideas. Studies using brain imaging show that when people are conscious, activity is widespread and coordinated across different regions. When they lose consciousness, whether through anesthesia, seizures, or brain injury, this global integration breaks down. Consciousness seems to depend on communication across the cortex and between the cortex and thalamus. But here's the puzzle. None of these theories explain why integrated information or global broadcasting should feel like anything from the inside. They describe the functions and mechanisms, but not the subjective experience. Why does widespread information sharing feel like seeing red or feeling joy? Why does it feel like something to be in that state at all? This is the heart of the hard problem. The brain clearly shapes consciousness, yet we cannot reduce consciousness to brain activity alone. There are also cases where the link between brain and consciousness is less clear. Some patients in vegetative states, unresponsive and seemingly unconscious, have shown surprising brain activity. In famous studies, researchers asked these patients to imagine playing tennis or walking through their home. Brain scans revealed activity in the same regions as healthy people imagining those tasks. Though outwardly unresponsive, some patients demonstrated inner awareness. This raises questions about how much consciousness can exist in damaged or inactive brains, and whether our current definitions are too narrow. Split brain research provides another perspective. In patients who have had their corpus callosum, the bridge between the brain's hemispheres, severed to treat epilepsy, each hemisphere operates somewhat independently. In experiments, one hemisphere can recognize objects the other cannot, leading some researchers to suggest that two streams of consciousness may exist within a single skull. This challenges our intuitive sense of a unified self and suggests that consciousness is deeply tied to brain structure. Taken together, these findings paint a powerful picture. The brain and consciousness are intimately linked. Damage, drugs, sleep, or surgical changes all alter awareness. Yet the link is not absolute proof that the brain creates consciousness. It only shows correlation. Just as pressing buttons on a radio changes the music without creating it, altering the brain may shape consciousness without producing it from scratch. Critics of brain-only models point out that even the most advanced neuroscience does not close the explanatory gap. We can describe correlations endlessly, but correlation does not equal causation. Consciousness might emerge from brain activity, or the brain might act as a conduit for something more fundamental. This uncertainty leaves open the possibility that consciousness could exist without a brain, though science has yet to prove it. What we do know is that the brain is an extraordinary organ, capable of producing, or at least shaping, the rich inner lives we lead. It gives rise to memory, creativity, identity, and imagination. Yet the very fact that we can ask whether consciousness transcends it shows how mysterious awareness remains. Even as neuroscience advances, the essence of subjective experience remains just beyond reach. The question of whether consciousness could exist without a brain is not just a scientific inquiry, it is also a deeply philosophical one. For centuries, philosophers have debated the nature of mind, the relationship between mind and body, and whether awareness is reducible to matter or something entirely distinct. While science provides data and experiments, philosophy provides the frameworks we use to interpret those findings. To truly explore this mystery, we need to examine the different philosophical perspectives that have shaped our understanding of consciousness. Let's begin with dualism, one of the oldest and most influential ideas in the philosophy of mind. Dualism, famously championed by René Descartes in the 17th century, holds that mind and body are two fundamentally different substances. The body, including the brain, belongs to the physical world. The mind, by contrast, is immaterial, belonging to the realm of thought and experience. Descartes expressed this distinction in his famous phrase, "I think, therefore I am." He argued that while the body could be doubted, it might be an illusion or a dream, the act of thinking was undeniable proof of the self's existence as a non-physical entity. Dualism provides a natural explanation for the idea that consciousness could exist without a brain. If mind and body are separate, then the mind might continue after the body ceases to function. This aligns closely with religious and spiritual traditions that speak of a soul surviving death. It also resonates with experiences like near-death visions or memories of past lives, which some interpret as evidence of consciousness beyond the body. However, dualism faces serious challenges. If the mind is truly immaterial, how does it interact with the physical brain? How can something non-physical cause neurons to fire? Or how can neural activity influence thoughts? Philosophers call this the interaction problem, and it remains one of the major criticisms of dualism. On the other side of the spectrum lies materialism, also known as physicalism. Materialism argues that everything that exists is physical, including consciousness. According to this view, the mind is not a separate substance, but a product of physical processes in the brain. Thoughts, feelings, and awareness all emerge from neural activity. Once the brain stops, consciousness ceases. This perspective is widely held among neuroscientists today, as it fits with the evidence showing that changes in brain activity produce changes in consciousness. Materialism, however, struggles with the hard problem of consciousness. Even if we describe every physical process in the brain, we still cannot explain why those processes should give rise to subjective experience. We can explain how neurons generate vision, but not why seeing red feels like anything at all. Some materialists respond by arguing that consciousness is just a byproduct, or epiphenomenon, of physical processes, a kind of shadow with no independent existence. But many philosophers find this unsatisfying, as it reduces the richness of conscious life to a side effect with no real causal power. Between dualism and materialism lies a range of alternative views. One of the most intriguing is Panpsychism. Panpsychism holds that consciousness is a fundamental feature of the universe, present in all matter to some degree. According to this view, atoms, molecules, and even stars might possess some rudimentary form of experience, however minimal. Human consciousness would then be a complex, integrated form of this universal property. Panpsychism bypasses the hard problem by suggesting that consciousness does not need to emerge from matter, because it is already inherent in matter. The brain, instead of creating consciousness, organizes and channels it into the rich inner lives we experience. Panpsychism has been gaining renewed attention in recent years, with philosophers like Philip Goff and Galen Strawson arguing that it offers the most coherent explanation of consciousness. It avoids the interaction problem of dualism by not separating mind and matter, and it avoids the explanatory gap of materialism by making consciousness a basic property of reality. Critics, however, argue that panpsychism leads to its own puzzles. If everything has consciousness, how do tiny sparks of awareness in particles combine into the unified consciousness we experience? This is known as the combination problem, and it remains one of the biggest challenges for panpsychist theories. Another philosophical approach is idealism, which flips the materialist view on its head. Idealism argues that consciousness is the primary reality, and the physical world emerges from it. In this view, the universe itself is a kind of vast consciousness, and what we perceive as matter is simply patterns within it. This perspective can be found in Eastern philosophies such as Advaita Vedanta, as well as in Western thinkers like George Berkeley, who argued that reality consists of minds and ideas, not material objects. If idealism is correct, then consciousness does not depend on the brain at all. Rather, the brain is a manifestation within consciousness. Closely related to this is the notion of the brain as a filter or receiver. Philosophers like William James and Henri Bergson suggested that the brain does not produce consciousness but limits and channels it. Just as a radio filters radio waves into audible sound, the brain filters a broader field of consciousness into human experience. This explains why damage to the brain alters awareness. The filter is disrupted, but the field itself remains. Such a model allows for consciousness to exist beyond the brain, with the brain merely acting as a temporary tuning device. Then there is functionalism, a more modern approach that emerged in the 20th century. Functionalism argues that consciousness is defined not by its physical substrate, but by its functions. In this view, what matters is the organization of processes and information flow, not the material they are built from. Just as a computer program can run on different hardware, consciousness could, in theory, exist in any system that performs the right functions. This opens the possibility of artificial consciousness, where machines or digital systems could one day achieve awareness. If functionalism is true, then consciousness could exist without a biological brain, provided there is some other structure capable of replicating its functions. Philosophical debates also draw on thought experiments to highlight the mystery of consciousness. One famous example is the philosophical zombie. Imagine a being that looks and behaves exactly like a human, with all the same brain processes and behaviors, but without any subjective experience. From the outside, it appears conscious, but inside, it is dark. If such a zombie is conceivable, it suggests that physical processes and consciousness are not the same thing. Another thought experiment is Mary's Rust, proposed by philosopher Frank Jackson. Imagine a scientist named Mary who knows everything about color vision, the physics, the biology, the neuroscience, but has lived her whole life in a black and white room. When she finally sees red for the first time, she learns something new: what red looks like. This suggests that subjective experience, or qualia, cannot be reduced to physical information alone. Each of these philosophical perspectives, dualism, materialism, panpsychism, idealism, functionalism, offers a different lens through which to consider whether consciousness can exist without a brain. None of them has achieved universal acceptance because each faces challenges. Dualism struggles with the interaction problem. Materialism struggles with the hard problem. Panpsychism struggles with the combination problem. Idealism struggles with explaining the consistency of the physical world. Functionalism struggles with proving that function alone is sufficient for subjective experience. Yet together, these theories show just how deep the mystery runs. It is also worth noting that philosophy and science often intersect here. For example, functionalism inspires artificial intelligence research, where scientists wonder if machines might one day become conscious. Panpsychism aligns with quantum theories that suggest consciousness may be woven into the fabric of reality. Dualism resonates with near-death experiences and reports of consciousness persisting without brain activity. Each philosophical framework provides a way to interpret the strange data we observe. What becomes clear is that consciousness is not easily confined to a single explanation. It challenges the boundaries between science and philosophy, between physical and metaphysical, between the known and the unknown. The very act of asking whether consciousness could exist without a brain forces us to confront our deepest assumptions about reality. Are we just biological machines, or are we expressions of something more profound? Is consciousness a fleeting spark, or is it the ground of being itself? In exploring these philosophical perspectives, we come face to face with the limitations of human understanding. Yet these limitations are not failures, they are invitations. They invite us to imagine new possibilities, to stretch our minds beyond familiar frameworks, and to embrace the mystery that consciousness represents. Whether or not we ever discover a final answer, the search itself enriches our understanding of who we are and what it means to exist. If consciousness is only the product of brain activity, then it should follow clear and predictable rules. Certain brain states should always correspond to certain conscious states. Yet in practice, we find anomalies, experiences, and case studies that do not fit neatly into the brain-only model. These phenomena do not necessarily prove that consciousness can exist without a brain, but they open cracks in the purely materialist explanation and hint at something deeper. One of the most striking examples is the out-of-body experience, often abbreviated as OBE. During an OBE, people report perceiving themselves from a perspective outside their physical body. They may float above, looking down at their body, or move through space as though untethered. OBEs are reported during trauma, surgery, meditation, or even spontaneously. While skeptics argue they are hallucinations, some OBEs include verifiable details that the person could not have perceived from their physical position. In one famous study, researchers placed hidden objects on high shelves in hospital rooms, hoping to catch reports from patients who had OBEs during cardiac arrest. Though the results have been mixed, the very possibility challenges our assumptions about the limits of perception and consciousness. Near-death experiences, which we briefly discussed earlier, overlap with OBEs but often include additional elements. Tunnels, lights, life reviews, or encounters with deceased relatives. These experiences are remarkably consistent across cultures, suggesting they tap into something universal in human consciousness. Skeptics point to brain chemistry, oxygen deprivation, or endorphins as explanations. Yet the richness, clarity, and timing of these reports, sometimes occurring when the brain shows minimal activity, raise questions that simple biochemical explanations cannot fully resolve. Another fascinating area is the phenomenon of terminal lucidity. People with severe dementia or neurological damage sometimes regain full clarity shortly before death. Imagine a patient who has not spoken or recognized loved ones for years suddenly holding a lucid conversation the night before passing away. If consciousness is entirely dependent on the brain, how is such a rebound possible when the neural structures are so degraded? While some scientists suggest it could be due to transient brain chemistry changes, others argue it may point to consciousness existing independently of the physical brain. Savants provide another puzzle. Savant syndrome occurs when individuals, often with severe cognitive impairments, demonstrate extraordinary abilities in narrow domains, such as mathematics, art, or memory. For example, a savant might instantly calculate complex prime numbers, reproduce a cityscape from memory after a single glance, or recall the precise date of every day over decades. These abilities seem to bypass ordinary learning and memory mechanisms, raising questions about where such knowledge or capacity comes from. Is the brain tapping into hidden reserves, or could consciousness access information in ways we do not yet understand? Consider also the phenomenon of acquired savant syndrome. In rare cases, individuals develop extraordinary abilities after brain injury or trauma. A man with no prior artistic talent might become a skilled painter following a head injury. Another might suddenly gain musical ability after a stroke. These cases suggest that brain damage can sometimes unlock capacities rather than diminish them. If the brain is purely a generator of consciousness, why would damaging it sometimes enhance abilities? Some theorists suggest the brain normally filters or inhibits certain information, and when those filters are disrupted, latent potentials emerge. This aligns with the idea of the brain as a limiter rather than a producer of consciousness. Altered states of consciousness also provide clues. Psychedelics like LSD, psilocybin, and DMT profoundly alter perception, dissolving the boundaries of self and creating experiences of unity with the universe. Brain imaging studies show that these substances reduce activity in the default mode network, a set of regions linked to self-referential thought. Paradoxically, when brain activity decreases in this network, subjective experience expands dramatically. Users often describe these experiences as more real than ordinary life, filled with insights and encounters that defy simple explanation. While materialists interpret this as brain chemistry generating illusions, others see it as the brain loosening its grip and allowing consciousness to access wider realities. Another anomaly comes from cases of veridical perception during altered states. Some individuals report gaining information they could not have known otherwise, such as seeing events in distant places or correctly describing hidden objects. Though such reports are controversial and difficult to verify scientifically, they add to the mystery of whether consciousness can sometimes extend beyond the brain. We also encounter strange cases in neurology. Consider patients with split brains whose corpus callosum connecting the two hemispheres has been severed. Experiments reveal that each hemisphere can operate semi-independently, with its own perceptions and intentions. One hand may button a shirt while the other unbuttons it. In some cases, patients give conflicting answers depending on which hemisphere is questioned. This raises the unsettling possibility of two centers of consciousness within one person, showing that consciousness is not necessarily unified and may not map neatly onto a single brain. Phantom limb syndrome offers another perspective. Amputees often continue to feel sensations in limbs that are no longer there. Sometimes these sensations are painful, as though the missing hand or foot still aches. Neuroscience explains this as the brain's representation of the body persisting even after the limb is gone. But the vividness of these sensations highlights how consciousness can create realities independent of physical structures. The body you feel is not the body you physically have, but the one your consciousness constructs. Cases of extreme memory also challenge our understanding. Some individuals, known as hyperthymestics, can recall nearly every day of their life in detail, as though they are reliving the past. Others demonstrate photographic memory, instantly capturing complex information. While neuroscience can map memory circuits, it struggles to explain the extraordinary variations between individuals. Could memory sometimes tap into fields beyond the physical brain, or are these abilities simply rare expressions of its hidden potential? An equally intriguing puzzle comes from children who recall past lives with startling accuracy. In some documented cases, children provide names, places, and events from lives they could not have known, later verified through investigation. While skeptics dismiss these as coincidences or suggestive questioning, the consistency and detail in some cases leave researchers puzzled. If true, they imply that consciousness might persist beyond the brain and even carry information across lifetimes. Even within ordinary life, consciousness shows strange capacities. Intuition, for example, often produces insights without deliberate reasoning. People sometimes make decisions or solve problems through sudden flashes of understanding, as though the answer appeared fully formed. In extreme cases, intuition has saved lives. Someone changes plans at the last minute, avoiding disaster, or feels compelled to check on a loved one at exactly the right time. While psychology explains this as unconscious pattern recognition, the accuracy and timing of some intuitions fuel speculation about consciousness reaching beyond the brain. Consider also near-sleep states, such as hypnagogia and hypnopompia. In these liminal moments between waking and sleeping, people often experience vivid imagery, voices, or sensations. Some report out-of-body experiences or encounters with otherworldly beings. While neuroscientists see these as products of the transitioning brain, the richness and consistency of these states across cultures suggest they may offer a window into deeper layers of consciousness. Taken together, these anomalies form a tapestry of mystery. Each one, out-of-body experiences, near-death visions, terminal lucidity, savant abilities, altered states, split brain cases, phantom limbs, extreme memory, past life recall, and intuition, challenges the neat story that consciousness is simply brain activity. None of them prove that consciousness exists without a brain, but collectively they suggest that the brain-only model may be incomplete. What unites many of these cases is the theme of expansion. Consciousness appears capable of reaching beyond normal boundaries, perceiving without sensory input, recalling without experience, creating without prior skill, persisting without neural support. The brain seems to constrain and shape consciousness, but perhaps it does not define its ultimate limits. This does not mean we abandon science for speculation. Rather, it means that science itself must stretch to account for what people actually experience. Skeptics rightly point out that extraordinary claims require extraordinary evidence. Many of these anomalies lack rigorous proof, and human perception is prone to error. Yet dismissing them entirely would be premature. History shows that phenomena once dismissed as impossible often later become understood. Lightning was once thought divine, dreams were once thought meaningless, and germs were once invisible myths. Consciousness itself may one day reveal similar surprises. The anomalies remind us that consciousness is not just an object of study, but the very medium through which we study. Every scientific experiment, every philosophical debate, every question we ask arises within consciousness. And so, when anomalies appear, when consciousness shows us something unexpected, they invite us to reconsider not only the brain, but the very nature of reality. Quantum physics is one of the strangest and most successful scientific frameworks ever developed. It explains the behavior of particles at the smallest scales. where the rules of everyday life seem to break down. At that level, objects can exist in superpositions, being in multiple states at once, until observed. Particles can also become entangled, meaning their states are linked no matter how far apart they are. Quantum mechanics defies intuition, but it has been tested countless times and underlies technologies like lasers, transistors, and MRI machines. So what does any of this have to do with consciousness? Some researchers believe that consciousness may not be fully explainable through classical physics, the predictable mechanical laws governing the macroscopic world. Instead, they suggest it might be rooted in quantum processes, allowing it to transcend the limitations of the brain. This line of thought is controversial, but it opens fascinating possibilities. The first major idea is known as the OR theory, short for orchestrated objective reduction. Proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff, it suggests that consciousness arises from quantum computations within microtubules, which are structural components inside neurons. According to the theory, these microtubules can sustain quantum states that interact with each other, and when these states collapse, moments of conscious awareness occur. In this model, the brain is not just a classical computer processing signals, it is a quantum system whose computations cannot be simulated by ordinary machines. The OR theory is appealing because it connects two mysteries: consciousness and quantum collapse. Quantum collapse refers to the transition from a superposition to a definite state when observed. Penrose argued that this collapse is not random, but influenced by a deeper physical law tied to space-time geometry. Hameroff proposed that microtubules orchestrate this process in the brain, producing coherent conscious experience. If correct, this would mean that consciousness is woven into the fabric of the universe, not just generated by neurons. Critics, however, argue that the brain is too warm and noisy for delicate quantum states to survive. Quantum coherence is usually maintained only at extremely low temperatures, as in superconductors. The rapid decoherence expected in biological systems would prevent meaningful quantum computation. Proponents counter that microtubules may have protective properties, enabling coherence at brain temperatures. Experiments continue, but the debate remains unresolved. Even if OR is not correct, the idea that quantum processes play a role in consciousness persists. One reason is that the brain exhibits extraordinary efficiency and complexity. Neurons fire in patterns that cannot be fully captured by classical models. Memory, creativity, and subjective experience seem to involve more than just electrical impulses. Quantum models offer one way to explain this extra layer of depth. Quantum entanglement provides another intriguing connection. When particles are entangled, measuring one instantly influences the other, no matter how far apart they are. Einstein famously called this spooky action at a distance. Though entanglement does not allow faster-than-light communication, it demonstrates that the universe has non-local properties. That is, events are connected beyond classical space and time. Some researchers wonder whether consciousness itself might involve non-local entanglement. If brain processes tap into entangled states, it could explain phenomena where consciousness seems to extend beyond the body, such as veridical perceptions during near-death experiences or the strange synchronicities people sometimes report. Though evidence is limited, the hypothesis keeps resurfacing because it offers a framework for understanding consciousness as something more than localized brain activity. Another angle comes from the idea of the quantum vacuum, sometimes described as the zero-point field. Even in empty space, quantum fluctuations occur constantly, with particles popping in and out of existence. Some theorists propose that consciousness may connect to this fundamental field, using the brain as a receiver or modulator. In this view, the brain does not create consciousness, but rather tunes into it like a radio. The quantum vacuum could be the ocean of awareness from which individual minds arise. This aligns with certain interpretations in philosophy and spirituality. Eastern traditions like Vedanta and Buddhism have long spoken of consciousness as a universal field, with individual minds as waves upon that vast ocean. The idea that physics might support such a view is compelling, though still highly speculative. Beyond microtubules and entanglement, some scientists look at quantum tunneling, the phenomenon where particles pass through barriers they should not be able to cross. In the brain, tunneling could affect synaptic processes, influencing how signals are transmitted between neurons. If quantum tunneling plays a role in thought and memory, it may hint at ways consciousness exploits the quantum domain to achieve feats that classical computation cannot. Quantum mechanics also reshapes how we think about the act of observation. In experiments like the double slit, particles behave differently depending on whether they are observed. This has led to debates about whether consciousness itself collapses the wave function. While most physicists reject this interpretation, preferring to see observation as an interaction with a measuring device, the role of consciousness in quantum mechanics remains philosophically puzzling. Some interpretations, such as the participatory anthropic principle proposed by physicist John Wheeler, suggest that consciousness is not just a byproduct of the universe, but an active participant in bringing reality into being. If this is true, consciousness is not merely housed within brains, but interwoven with the cosmos. The universe might require consciousness to actualize its potential states. This radical view blurs the line between physics and metaphysics, challenging the very meaning of existence. Quantum biology provides a growing field of evidence that quantum effects can occur in living systems. Birds appear to navigate using quantum entanglement in proteins within their eyes, allowing them to sense Earth's magnetic field. Photosynthesis, one of the most vital processes on Earth, seems to exploit quantum coherence to maximize energy transfer. If plants and animals already harness quantum processes for survival, it becomes less implausible that the brain might also rely on them in ways we do not yet fully grasp. These possibilities point to an exciting but uncertain frontier. On one hand, quantum theories of consciousness promise a framework where subjective experience could be explained in terms of fundamental physics. On the other hand, they risk overextending scientific concepts into realms where empirical support is thin. The challenge is to distinguish metaphor from mechanism, speculation from data. Yet even critics admit that consciousness is unlike any other phenomenon science has tackled. The subjective quality of experience, the unity of perception, the sense of self, all resist reduction to simple brain mechanics. If quantum physics has taught us anything, it is that reality is stranger than we can imagine. Perhaps consciousness too requires embracing strangeness. The quantum approach also reshapes how we think about the brain's role. If the brain is a receiver or filter of a wider consciousness field, then its function is not to generate awareness but to localize it. Damage to the brain might distort the reception, just as a damaged radio garbles a signal, but the source of consciousness remains beyond. This would explain why consciousness sometimes appears to expand in altered states or persist when the brain is inactive. If consciousness is indeed connected to quantum fields or non-local processes, then it might not be bound by the limits of biology. It could, in principle, exist without a brain, just as radio waves exist without a receiver. Brains allow consciousness to interact with the physical world in specific ways, but they may not be the origin of consciousness itself. Of course, these ideas remain speculative. Orc-OR has not been conclusively demonstrated. Non-local consciousness has not been empirically verified. The connection between quantum mechanics and subjective awareness is more philosophical than experimental. But the very fact that serious scientists entertain these possibilities shows how deep the mystery of consciousness runs. At the heart of this debate lies a paradox. Science seeks objective explanations, but consciousness is intrinsically subjective. To study it is to try to step outside of it, a task that may be impossible. Quantum mechanics, with its observer-dependent reality, mirrors this paradox. Both consciousness and quantum physics remind us that reality is not as straightforward as it seems. By exploring quantum theories, we are not claiming final answers, but opening doors. These doors may lead to breakthroughs or dead ends, but they expand our imagination about what consciousness could be. Could it be fundamental, like space and time? Could it exist independently of matter, or even give rise to matter itself? These are questions that touch not only on science, but also on meaning, identity, and our place in the cosmos. Perhaps the greatest lesson from the quantum approach is humility. We do not yet know what consciousness is, but we must be willing to question assumptions. If the brain is not the whole story, then consciousness may be the bridge between the physical and the metaphysical, the known and the unknown. It may connect us not only to our own thoughts, but to the fabric of the universe. Philosophy has always been at the heart of questions about consciousness. Long before neuroscience and quantum physics, thinkers were already asking whether the mind could exist without the body. Some framed the mind as a soul, eternal and independent of matter. Others saw it as an emergent property of the brain, ceasing when neurons stop firing. Between these extremes lies a vast landscape of theories, each one attempting to answer one of the deepest questions humanity has ever faced. What is consciousness, and does it require a brain? One of the oldest positions is dualism, most famously associated with René Descartes in the 17th century. Descartes argued that mind and body are two distinct substances. Res cogitans, the thinking thing, and res extensa, the extended thing. In his view, the mind was immaterial and indivisible, while the body was material and divisible. He believed that the two interacted through the pineal gland, though the exact mechanism remained mysterious. Dualism offered a way to preserve the idea of an immortal soul, separate from the body, and resonated with religious traditions that emphasized life after death. Dualism faces a persistent challenge, the problem of interaction. If the mind is immaterial, how does it influence the body? How can something outside the physical world cause neurons to fire or muscles to move? Critics argue that dualism violates the conservation of energy and introduces a causal gap. Yet despite centuries of criticism, dualism refuses to fade away. Many people intuitively feel that their consciousness is more than just brain activity, and dualism gives voice to that intuition. On the other side stands materialism or physicalism, which holds that consciousness is nothing more than brain processes. According to this view, the mind emerges from the complex interactions of neurons and synapses, just as a hurricane emerges from air pressure and temperature. When the brain ceases to function, consciousness ends. Physicalism is the dominant position in modern neuroscience and philosophy of mind because it aligns with empirical evidence. Brain injuries, drugs, and electrical stimulation all alter consciousness in predictable ways, suggesting a close dependence on neural mechanisms. Yet materialism struggles with the so-called hard problem of consciousness, articulated by philosopher David Chalmers. The hard problem asks, why is there subjective experience at all? Even if we map every neuron and understand every function, why does it feel like something to see red, taste chocolate, or feel joy? Functional explanations account for behavior, but they do not explain qualia, the raw feel of experience. This gap leaves room for alternative philosophies. One of these alternatives is Panpsychism, which has gained renewed attention in recent years. Panpsychism proposes that consciousness is not exclusive to humans or even animals, but is a fundamental property of the universe, present to some degree in all matter. Just as mass and charge are basic features of reality, so too is consciousness. According to Panpsychism, electrons, rocks, and trees possess tiny glimmers of experience, which combine in complex systems like the human brain to create richer awareness. Panpsychism avoids the hard problem by not trying to derive consciousness from non-conscious matter. Instead, it assumes that consciousness is already there, woven into the fabric of existence. Critics dismiss it as absurd, pointing out that attributing experience to inanimate objects seems counterintuitive. But defenders argue that it may be no stranger than the alternatives. After all, how does lifeless matter suddenly become conscious when arranged in a brain? Panpsychism sidesteps this leap by starting with consciousness as fundamental. A related but distinct philosophy is Idealism, which reverses the materialist picture entirely. In Idealism, consciousness is primary and matter is secondary. According to this view, what we call the physical world is a manifestation or projection of consciousness. Philosophers like George Berkeley argued that objects exist only insofar as they are perceived. Modern versions of idealism suggest that reality is a mental construct and the brain is simply a feature within consciousness, not the generator of it. Idealism radically shifts the question. If matter arises within consciousness, then consciousness obviously can exist without the brain, since the brain itself is part of the conscious field. This perspective aligns with mystical traditions and some interpretations of quantum physics. It suggests that what we take as objective reality is more like a shared dream within a universal mind. While difficult to prove, idealism remains a powerful way of reframing existence. Another important perspective is functionalism, which focuses not on what consciousness is made of, but what it does. Functionalists argue that consciousness depends on the organization of processes, not the specific material. In this view, if another system, say a computer or artificial intelligence, were organized like a human brain, it could also be conscious. This raises questions about whether consciousness could exist in machines, or even across networks, independent of biological brains. Functionalism sidesteps debates about substance, but raises its own puzzles. Could consciousness really emerge from silicon circuits or code? Or is there something about biological matter that is essential? Advocates of functionalism believe the substrate does not matter. Skeptics argue that human experience is deeply tied to organic processes. If functionalism is correct, however, then consciousness might someday migrate from brains to other forms, existing without biology altogether. Property dualism offers a middle ground between materialism and traditional dualism. It suggests that while the brain is physical, it possesses non-physical properties, namely consciousness. These properties do not reduce to physical laws, but arise from them in irreducible ways. In other words, consciousness is not separate from the brain, but is not explainable solely in terms of neurons either. This preserves the uniqueness of subjective experience while maintaining a physical basis. Philosophy also confronts the possibility of disembodied minds. If consciousness can exist without a brain, what form would it take? Could it be pure thought, unanchored by senses or memory? Would it retain identity or dissolve into a larger whole? Dualism and idealism suggest survival beyond the body is possible, while physicalism denies it. Panpsychism implies continuity, but not necessarily individuality. The answers depend on which metaphysical lens one adopts. Interestingly, ancient philosophies often anticipated these debates. Hindu traditions describe the Atman, the eternal self beyond the body. Buddhism spoke of consciousness as a stream of moments, continuing through rebirths. Plato envisioned the soul existing before and after the body, while Aristotle saw the soul as the form of the body, inseparable from it. These views echo in today's scientific and philosophical explorations, reminding us that the mind-body question is both ancient and enduring. Modern philosophy also examines the relationship between information and consciousness. Some theorists, like Giulio Tononi with his integrated information theory, 1IT, argue that consciousness corresponds to the degree of integrated information in a system. The more unified and irreducible the informational structure, the more conscious it is. This theory allows for the possibility that non-biological systems, or even the universe itself, could have consciousness, depending on how information is organized. From this standpoint, the brain is one particular instantiation of a conscious system, but not the only possible one. Consciousness could, in principle, exist in other substrates, so long as they achieve sufficient informational integration. This idea bridges philosophy and neuroscience, suggesting measurable criteria for consciousness while expanding its potential beyond biology. The debate between these perspectives is far from settled. Physicalists emphasize the empirical link between brain activity and consciousness, arguing that damage to specific regions predictably alters perception, memory, and selfhood. Dualists counter that correlation does not equal causation, and that the brain may be a conduit rather than the source. Panpsychists insist that trying to generate consciousness from non-conscious matter is a category mistake. Idealists turn the whole discussion upside down by denying that matter exists independently at all. Each position has strengths and weaknesses, and none has yet achieved consensus. What makes the question so difficult is that consciousness is both the most immediate reality and the hardest to explain. We cannot step outside of it to measure it directly, and we cannot reduce it to equations without losing its essence. Science provides invaluable insights into how the brain works, but philosophy remains essential for grappling with what consciousness is. In considering whether consciousness could exist without a brain, philosophy offers both caution and inspiration. It reminds us that definitions matter. If we define consciousness strictly as the biological processes of the human brain, then of course it cannot exist without one. But if we define it as awareness, subjectivity, or even information, then the door opens to many possibilities. Consciousness might be fundamental, emergent, or universal. It might vanish with the brain, or transcend it. Perhaps the most honest conclusion is that we simply do not know. Philosophy does not provide definitive answers, but it clarifies the questions, showing us the assumptions behind each stance. Is consciousness a product, a property, or the foundation of reality itself? The answer determines not only whether it can exist without a brain, but also what it means to be human. Ultimately, philosophy keeps the mystery alive. It challenges us to consider that our everyday experience, the simple act of being aware, might be far stranger and more profound than we realize. Whether it emerges from neurons, arises from universal principles, or forms the very ground of reality, consciousness invites us to explore beyond the boundaries of science and into the depths of meaning itself. For centuries, people have reported experiences that suggest consciousness might not be tied exclusively to the brain. These accounts include near-death experiences, out-of-body journeys, telepathy, precognition, and memories of past lives. Collectively, they form the subject matter of parapsychology, a field dedicated to studying phenomena that sit at the edges of mainstream science. While parapsychology is controversial, it continues to attract interest because it deals with questions that touch directly on our deepest fears and hopes. Is there more to us than the body? And does consciousness survive beyond death? One of the most widely studied phenomena is the near-death experience, often abbreviated as NDE. These occur when people are clinically dead or close to death, but later revived. Reports of NDES are strikingly consistent across cultures. Individuals describe leaving their bodies, floating above hospital beds, and observing medical staff working to resuscitate them. Many recall traveling through a tunnel toward a bright light, encountering deceased loved ones, or feeling an overwhelming sense of peace and unconditional love. Some even describe panoramic life reviews, where their entire existence plays out before them in vivid detail, accompanied by a profound sense of moral insight. From a neuroscientific perspective, skeptics argue that NDES can be explained as hallucinations caused by a lack of oxygen to the brain, the effects of anesthesia, or the release of neurochemicals like endorphins or ketamine-like compounds. Studies of brain activity in dying animals show surges of gamma oscillations shortly after cardiac arrest, suggesting a burst of neural activity could generate vivid experiences. In this view, NDES are the brain's final fireworks display. Yet NDE researchers point out that many accounts include verifiable details. People have described medical procedures in detail while unconscious, or noticed objects in the operating room that they could not have seen from their physical position. In one famous case, a woman undergoing brain surgery reported hearing conversations and seeing instruments while her brain was cooled to the point of flatlined activity. Critics counter that memory may be reconstructed after the fact, or that subtle residual activity could sustain awareness, but such cases remain difficult to explain fully. Another phenomenon closely tied to NDES is the out-of-body experience, or OBE. OBES are reported not only in near-death situations, but also in meditation, trauma, or even spontaneously during sleep. People describe floating above their physical bodies, traveling through space, and observing distant locations. Experiments have attempted to test OBEs by placing hidden targets on high shelves in hospital rooms, hoping that patients who leave their bodies will be able to report them. The results are inconclusive, but some intriguing anecdotes persist. Neuroscience has identified brain regions linked to OBEs, particularly the temporoparietal junction. Electrical stimulation of this area can induce sensations of floating or seeing oneself from above. This suggests a neurological basis. However, the subjective reality of OBEs often feels more real than ordinary perception, leading experiencers to insist that consciousness truly separated from the body. Whether these are brain-generated illusions or glimpses of a non-local mind remains unresolved. Parapsychology also investigates reincarnation claims. Some young children spontaneously recall memories of past lives, often with remarkable detail. They may describe places, people, or events they could not have learned through ordinary means. The most famous research in this area was conducted by Ian Stevenson, a psychiatrist at the University of Virginia, who documented over 2,500 cases. He reported that some children not only remembered previous names and lives, but also bore birthmarks or deformities corresponding to injuries or wounds from those alleged past existences. Skeptics argue that cultural influence plays a major role, especially in societies where reincarnation is part of religious belief. Parents may unintentionally reinforce children's fantasies, or memories may emerge from overheard conversations. Yet some cases involve verifiable details of obscure individuals, making coincidence less likely. Even if not proof of reincarnation, these cases raise questions about memory and identity, and whether consciousness can access information beyond one lifetime. Another area of parapsychology involves CSI phenomena, such as telepathy, clairvoyance, and precognition. Laboratory experiments have attempted to test whether people can receive information without sensory input. One method, the Ganzfeld experiment, places participants in a sensory-reduced environment, with halved ping-pong balls over the eyes, red light, and white noise. The sender attempts to transmit an image or video to the receiver telepathically. Some meta-analyses claim results slightly above chance, suggesting a small but statistically significant effect. Critics counter that methodological flaws, publication bias, and statistical noise undermine these findings. Similarly, experiments on precognition test whether people can anticipate future events. For example, subjects are asked to choose between two options, and only afterward is the target randomly selected. In some studies, participants performed better than chance, as if their decisions were influenced by events not yet determined. Psychologist Darrell Bem's controversial research in 2011 reported positive results, sparking heated debate. Replications have yielded mixed outcomes, and mainstream science remains skeptical. Still, the persistence of such experiments reflects the enduring fascination with the possibility that consciousness transcends time and space. One of the most intriguing aspects of parapsychology is its intersection with physics. Some researchers speculate that quantum mechanics may provide a framework for non-local consciousness. The phenomena of entanglement and superposition suggest that particles can influence each other instantaneously across vast distances. If consciousness is somehow linked to quantum processes, perhaps minds can connect or perceive beyond ordinary physical limits. This remains speculative, and many physicists caution against overextending quantum principles into parapsychology. Nevertheless, the parallels are provocative. The scientific establishment generally regards parapsychology with skepticism, if not outright dismissal. Critics argue that extraordinary claims require extraordinary evidence, and that parapsychological findings rarely withstand rigorous replication. Funding is scarce, and reputations can be damaged by association. Yet the field persists because the phenomena are deeply human. People continue to report experiences that feel undeniably real, whether or not they conform to laboratory standards. Beyond science, the cultural impact of these experiences is profound. NDEs often transform people's lives, leading to decreased fear of death, increased compassion, and a sense of spiritual awakening. OBES inspire curiosity about the nature of reality. Reincarnation stories shape beliefs about morality and destiny. Psi phenomena fuel myths, folklore, and art. Whether or not these experiences reveal literal truth about consciousness beyond the brain, they reveal psychological truth about what humans long for: connection, continuity, and meaning. One way to frame these experiences is through the idea of non-local consciousness. This perspective suggests that consciousness is not confined to the brain, but can extend beyond it, accessing information across space and time. The brain may act as a receiver or filter rather than a generator. This model resonates with metaphors of radios or televisions. The program does not originate in the device, but the device makes it manifest. If the brain functions as such a receiver, then extraordinary experiences might reflect moments when the filter loosens, allowing awareness to reach beyond the usual limits. Of course, such metaphors cannot replace evidence, but they offer a way of integrating anomalous experiences without discarding them as mere illusions. They also align with historical accounts of mystics, shamans, and spiritual practitioners who have long claimed to travel beyond the body, communicate across distances, or access timeless knowledge. From this perspective, parapsychology is not fringe, but a modern attempt to study age-old human experiences with scientific tools. It is worth noting that even within mainstream psychology, altered states of consciousness are recognized as real and significant. Hypnosis, meditation, psychedelic states, and flow experiences all reveal that the mind can operate in ways quite different from ordinary waking awareness. These states often blur the boundary between self and world, giving rise to insights or perceptions that feel otherworldly. While not necessarily evidence of consciousness beyond the brain, they demonstrate its vast potential and plasticity. Critics of parapsychology argue that human perception is easily fooled, memory is malleable, and belief strongly colors experience. They caution that anecdotal reports, however sincere, cannot substitute for controlled data. This is a valid concern, yet at the same time dismissing all anomalous experiences as error risks, overlooking something important. History shows that many once dismissed phenomena, such as meteorites, germs, or hypnosis, were eventually accepted after evidence accumulated. The challenge is maintaining both rigor and openness. For the individual who has had a near-death vision, floated above their body, or remembered a past life, the experience is more than an academic puzzle. It is often life-changing. Whether explained neurologically or spiritually, such moments leave lasting marks. They push people to reconsider what it means to be alive, what happens after death, and whether consciousness is truly bounded by the brain. Parapsychology, then, occupies a liminal space between science and spirituality. It does not provide definitive proof that consciousness exists independently of the brain, but it keeps the question alive. It forces us to confront experiences that do not fit neatly into current theories, inviting humility in the face of mystery. Even if most claims turn out to have conventional explanations, The persistence of these reports reminds us that human consciousness may not be fully captured by reductionist models. Perhaps the most important contribution of parapsychology is its willingness to ask forbidden questions. What if awareness does not end with brain death? What if memory can transcend lifetimes? What if minds can connect beyond space and time? These may remain unproven, but exploring them expands the horizons of human thought. Whether we conclude that such phenomena are windows into a greater reality, or simply reflections of the brain's complexity, they enrich our understanding of consciousness. As we sift through stories of near-death journeys, out-of-body travels, reincarnated memories, and psychic connections, we are confronted with a paradox. The evidence is tantalizing but not conclusive, suggestive but not definitive. Science demands caution, but the human spirit craves meaning. In this tension lies the heart of the mystery. Consciousness continues to surprise us, eluding simple categorization, hinting that it may be far more expansive than we imagine. In recent decades, advances in neuroscience and physics have brought us closer to understanding consciousness, though the mystery remains unresolved. Some theories remain grounded in classical brain science, while others reach into speculative frontiers of quantum mechanics and cosmology. Together, these approaches represent humanity's latest attempt to answer the oldest question: is consciousness confined to the brain, or does it extend beyond? Mainstream neuroscience begins with the assumption that consciousness emerges from neural activity. Billions of neurons, each firing electrical impulses, form intricate networks. The interactions of these networks give rise to perception, memory, and self-awareness. According to this view, when the brain ceases activity, consciousness ceases as well. Yet even within neuroscience, no consensus exists on how neural firing translates into subjective experience. This is known as the hard problem of consciousness, a term coined by philosopher David Chalmers. The hard problem highlights a gap between objective mechanisms and subjective reality. We can measure brain waves and map synapses, but we cannot yet explain why the experience of redness feels like it does, or why pain feels sharp and urgent rather than a neutral data point. Some scientists attempt to solve the hard problem through theories that reframe consciousness not as an emergent property, but as a fundamental feature of reality. One such theory is integrated information theory, IIT, proposed by neuroscientist Giulio Tononi. IIT suggests that consciousness corresponds to the capacity of a system to integrate information. In other words, a conscious system is one that generates a unified whole greater than the sum of its parts. The degree of consciousness can be mathematically measured by a quantity called phi, capital Phi. According to IIT, the brain is conscious because it integrates vast amounts of information across interconnected regions. This theory has the radical implication that any system with sufficient integration, whether biological or artificial, possesses some degree of consciousness. IIT reframes consciousness not as exclusive to humans, but as a property distributed across systems. A mouse has less consciousness than a human, but more than a simple circuit board. Even a thermostat, in a very minimal sense, could be said to have proto-consciousness because it integrates information. Critics argue that IIT risks panpsychism, the idea that consciousness pervades all matter, and that it cannot yet explain the specific qualities of subjective experience. Still, IIT remains one of the most influential contemporary theories, providing a bridge between neuroscience and philosophy. Another prominent model is global workspace theory, GWT, developed by Bernard Bars and expanded by Stanislas Dehaene. GWT compares the brain to a theatre in which many unconscious processes work backstage, while a spotlight of attention broadcasts information to a global workspace. Consciousness, in this view, arises when information becomes globally available, accessible to decision-making, memory, and language. Unlike IIT, GWT emphasizes accessibility and communication within the brain rather than integration. Neuroscientific experiments support this model, showing that conscious perception corresponds to widespread activation across cortical regions. GWT remains grounded in brain function, yet it opens the door to questions about whether other systems, like AI, might also achieve consciousness by broadcasting information globally. While these theories remain within the bounds of classical neuroscience, others venture into physics to explain consciousness. One of the most discussed is the OR model, orchestrated objective reduction, proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. According to OR, consciousness arises not from large-scale neural networks, but from quantum processes inside microtubules, tiny structural components of neurons. The theory suggests that quantum superpositions within microtubules collapse in orchestrated patterns, producing moments of conscious awareness. The OR model is controversial. Critics argue that the brain is too warm and noisy for delicate quantum states to persist, and that evidence for microtubule-based quantum processes is lacking. However, research into quantum biology has revealed surprising findings. For example, quantum coherence has been observed in photosynthesis and bird navigation, showing that quantum effects can play roles in biological systems. Whether they extend to consciousness remains unknown, but the possibility keeps the OR model alive as a provocative alternative. Another frontier theory comes from physics, the idea that consciousness is not generated by matter, but is itself a fundamental aspect of the universe, like space, time, or energy. This aligns with Panpsychism, which suggests that all matter contains some form of proto-consciousness. Philosopher Philip Goff has argued that Panpsychism may be the most parsimonious way to solve the hard problem. Rather than asking how matter produces mind, we accept that mind is already present at the most basic level. In this framework, atoms and particles contain rudimentary awareness, which becomes more complex in organized systems like brains. Though radical, Panpsychism echoes ancient philosophies from both East and West. In Vedantic traditions of India, consciousness is considered the ground of being, with matter arising from awareness rather than the reverse. Similarly, Western philosophers like Spinoza and Leibniz proposed forms of panpsychism centuries ago. The resurgence of this idea in modern science reflects a growing willingness to reconsider metaphysical assumptions. A related perspective is the notion that consciousness may be tied to the fabric of the universe itself. Some physicists have speculated that consciousness could emerge from the information structure of space-time. This resonates with John Wheeler's it from bit hypothesis, which claims that physical reality arises from information. If reality is fundamentally informational, then consciousness, our capacity to experience and interpret information, may be woven into the cosmos at its deepest level. Another line of research investigates whether consciousness can be understood through the lens of complexity and emergence. Complex systems often display properties not predictable from their components alone, such as the coordinated movement of bird flocks or the self-organization of ecosystems. Consciousness may be an emergent property of sufficiently complex systems, irreducible to individual neurons, yet fully dependent on them. This view avoids panpsychism while acknowledging that consciousness could be a natural result of complexity wherever it arises, whether in human brains, alien intelligence, or advanced artificial networks. Still, emergentist theories face the challenge of explaining qualia, the subjective qualities of experience. How does complexity translate into the what it is like aspect of consciousness? Why does a sufficiently complex brain not simply process information, but also feel? This is the crux of the hard problem, and it remains unsolved despite increasingly sophisticated models. In addition to these theoretical approaches, experimental science continues to probe the boundaries of consciousness. Neuroimaging techniques like fMRI and EEG allow scientists to observe brain activity in real time, correlating patterns with conscious states. Studies on anesthesia reveal the neural correlates of unconsciousness, while research on sleep and dreaming maps the shifting architecture of awareness. Experiments on patients in vegetative or minimally conscious states have shown that some retain hidden awareness, detectable only through brain scans when asked to imagine specific scenarios. These findings challenge assumptions about the limits of consciousness and raise ethical questions about care and personhood. Physics, too, is pushing the boundaries. Some researchers propose that black holes, with their immense density of information, may hold insights into the nature of consciousness. Others explore the holographic principle, which suggests that the universe itself may be a projection of information encoded on a distant surface. If reality is holographic, then consciousness may not reside in the brain alone, but participate in a deeper informational structure. Artificial intelligence provides another frontier for exploring consciousness. Advanced AI systems process vast amounts of data, recognize patterns, and even generate creative outputs. Some theorists argue that if consciousness arises from information integration or global broadcasting, AI could one day become conscious. Others maintain that AI, no matter how sophisticated, will always lack subjective awareness because it does not have biological embodiment or experiential continuity. The question of machine consciousness forces us to confront what we truly mean by awareness and whether our definitions are limited by human bias. Despite all these advances, the central mystery persists. Consciousness remains both intimate and elusive. We live within it constantly, yet struggle to define or measure it. Each theory offers a piece of the puzzle, but leaves unanswered questions. Integrated information theory quantifies, but does not explain qualia. Global workspace theory models attention, but not subjectivity. OR offers a quantum mechanism, but remains speculative. Panpsychism reframes the problem, but risks diluting consciousness into everything. Emergence accounts for complexity, but not inner life. Perhaps the resolution will come not from one theory, but from a synthesis. Consciousness may involve both classical and quantum processes, both brain-bound and universal properties, both emergent complexity and fundamental reality. Just as light can be both particle and wave, consciousness may be both generated by brains and rooted in the cosmos. Our scientific frameworks may need to expand, integrating physics, neuroscience, and philosophy in unprecedented ways. In the meantime, the exploration itself is valuable. Studying consciousness pushes science to its limits, forcing us to question assumptions about reality, identity, and existence. It blurs the line between objective and subjective, physics and metaphysics, matter and mind. Each new experiment, whether confirming or challenging our models, brings us closer to an understanding that may one day transform how we see ourselves in the universe. And perhaps this is the most important lesson. The mystery of consciousness is not a failure of science, but a sign of its vitality. Some of the greatest discoveries emerge from the questions we cannot yet answer. Whether consciousness turns out to be an emergent property of neural networks, a quantum field phenomenon, or a fundamental aspect of reality itself, the search reminds us that our minds are not just problem solvers, but explorers of the unknown. Consciousness is not merely a scientific puzzle, but a mirror reflecting our deepest wonder. To ask where it comes from is to ask what we are and what it means to exist at all. That is why neuroscience and physics, despite their differences, converge here, at the edge of the mystery, where science and philosophy meet, and where the story of consciousness continues to unfold. Consciousness is more than neural firing patterns. It is the fabric of experience itself. If it extends beyond the physical brain, then questions of identity, free will, and destiny shift dramatically. We must reconsider who we are, what happens when we die, and whether our awareness is uniquely human or a shared thread woven through the cosmos. Let's begin with the self. From a materialist perspective, the self is a construction of brain processes, memories, personality, and narrative coherence stitched together by neural activity. Damage the brain, and the self shifts. People with amnesia lose their sense of continuity. Those with brain injuries may undergo radical personality changes. This suggests that identity is fragile and dependent on biology. But if consciousness is not solely brain-based, the self might not end where neurons do. Perhaps memory and personality are expressions of consciousness filtered through the brain, rather than consciousness itself. If so, then identity may persist beyond physical structures, in a form not yet understood. This leads naturally to the question of death. Under strict materialism, death marks the end of consciousness, just as the extinguishing of a flame ends its light. Yet many philosophical traditions and near-death accounts suggest otherwise. If consciousness is fundamental, then death may represent not an annihilation, but a transition, an unbinding of awareness from its bodily anchor. This does not prove life after death, but it keeps the door open to possibilities beyond extinction. Philosophically, this is both unsettling and liberating. It means our lives are not necessarily confined to a finite arc of years, but could be part of a larger continuum. The implications extend to free will. If consciousness is an emergent property of deterministic neural networks, then our sense of agency may be an illusion, the result of complex causal chains firing in predictable patterns. But if consciousness is fundamental or universal, it may hold a level of autonomy beyond physical causation. Free will could be real, not in the sense of random choice, but as genuine agency arising from awareness itself. This reframes responsibility and creativity. We are not mere puppets of neurochemistry, but participants in shaping reality. The debate over free will has long divided philosophers, but placing consciousness at the foundation of existence breathes new possibility into human choice. Expanding the question further, we can ask, if consciousness is not confined to the brain, does it permeate the universe? This idea finds echoes in ancient and modern thought alike. In Hindu philosophy, Atman, the individual self, is ultimately identical with Brahman, the universal consciousness. In Buddhist traditions, awareness is seen as fundamental, with the self being an impermanent construct. In Western mysticism, the concept of a divine spark reflects the same intuition, that consciousness links us to something larger. If science eventually affirms a universal aspect to consciousness, these ancient intuitions would gain unexpected validation. This cosmological dimension reshapes humanity's place in the universe. For centuries, science has displaced human centrality. Earth is not the center of the cosmos. Species evolve through natural processes, and the brain is a biological organ like any other. Yet consciousness might restore a new kind of significance. If awareness pervades reality, then our minds are not isolated accidents, but expressions of the universe becoming aware of itself. Carl Sagan once said, "We are a way for the cosmos to know itself." If consciousness is indeed woven into the fabric of existence, this statement may be literally true. But what does it mean for the universe to know itself? One possibility is that consciousness is the universe's method of self-reflection. Just as neurons form networks in the brain, galaxies form networks in the cosmos. Some scientists have noted structural similarities between the large-scale web of galaxies and the neural networks of brains. If such analogies hold deeper meaning, then consciousness may not only exist within brains, but also within cosmic structures. Awareness in this vision scales from micro to macro, from the quantum vacuum to the galactic web. This raises profound questions about extraterrestrial life. If consciousness is universal, then intelligent beings elsewhere are not simply accidental products of evolution, but inevitable manifestations of awareness-seeking expression. The discovery of alien intelligence would confirm that consciousness arises wherever complexity allows, suggesting that the universe is fertile with mind. But even without such discoveries, the very possibility reframes our search. We are not alone in seeking meaning, but part of a vast community of potential awareness scattered across the stars. Returning to human experience, the idea of consciousness beyond the brain also affects ethics. If consciousness is fundamental, then it may extend to animals, ecosystems, or even artificial systems in ways we have not fully acknowledged. This deepens the moral weight of our actions. If a dolphin or an octopus has not only intelligence, but also participation in a universal field of awareness, then their lives carry significance beyond utility. If ecosystems themselves embody forms of consciousness, then environmental destruction is not merely material harm, but the disruption of a living web of awareness. Ethics expands from human-centered concerns to a cosmocentric responsibility. Philosophically, this also challenges the reductionist view of reality as dead matter. If consciousness is primary, then the universe is not a cold machine, but a living process. Matter becomes secondary, a crystallization of awareness rather than its source. This resonates with idealist philosophies which claim that reality is fundamentally mental or experiential. George Berkeley, the 18th century philosopher, argued that to be is to be perceived, suggesting that existence itself depends on consciousness. While materialism has dominated modern science, idealism is resurfacing as a serious contender in consciousness studies. Still, we must avoid simplistic conclusions. Theories that extend consciousness beyond the brain are not without critique. Skeptics argue that panpsychism dilutes meaning, making everything conscious in ways that seem trivial. Others contend that universal consciousness explanations verge on mysticism rather than science. These criticisms are valuable because they keep the debate grounded, preventing speculation from replacing evidence. Yet even skeptics must admit that the hard problem remains unsolved, and materialism has not delivered a full account of subjective experience. This tension between science and philosophy may be precisely what consciousness demands. It resists being neatly categorized because it is the very ground of categorization. To study consciousness is to use consciousness itself as both tool and subject. This circularity may frustrate reductionist approaches, but also points to a deeper truth, that awareness is not just another phenomenon, but the condition of all phenomena. It cannot be fully objectified because it is the subject behind all observation. In this light, the quest to understand consciousness becomes a mirror for our deepest longings. We are not only seeking explanations, but also seeking ourselves. To ask whether awareness can exist without a brain is also to ask whether our essence transcends mortality, whether meaning survives beyond matter, whether our lives are part of a greater whole. These questions are not merely scientific, but existential, shaping how we live, love, and act. One might argue that even if consciousness is brain-bound, the pursuit of meaning is no less profound. If awareness is a fleeting spark in a vast, indifferent cosmos, then its rarity makes it precious. But if consciousness is eternal, the significance shifts. We are not fragile anomalies, but participants in an ongoing unfolding of mind across time and space. Both perspectives carry weight. One emphasizes urgency, the other continuity. Together they frame the human condition in a spectrum of possibility. And perhaps this is the point. The mystery of consciousness invites humility. We do not yet know whether it ends with neurons or extends into the fabric of the universe. But in living the question, we gain perspective. We recognize that our awareness, however it arises, is extraordinary, a window onto existence itself. Whether temporary or timeless, it gives us the capacity to wonder, to imagine, to love, to create. These are not incidental byproducts of biology, but the very essence of being. Can meaning exist without matter? Can identity persist without form? Can awareness transcend its vessel? These are not merely speculative curiosities. They shape religions, philosophies, and personal lives. They touch our fears of death and our hopes for continuity. They inspire our art, our rituals, and our scientific endeavors. Consciousness is not simply a puzzle to be solved. It is the horizon against which we measure all human thought. In this sense, the debate itself is as important as its resolution. It reminds us that science and philosophy are not enemies but partners, each bringing tools to the table. Science measures and maps. Philosophy interprets and questions. Together they illuminate the mystery, even if they cannot yet resolve it. And perhaps resolution is not the goal. Perhaps the true gift of consciousness is that it resists final answers, keeping us forever engaged in the act of seeking. As we look outward into the cosmos and inward into the mind, we carry with us this paradox, that we are finite beings glimpsing infinity, that we are temporary forms of what may be eternal awareness. Whether consciousness requires a brain or transcends it, the fact that we can even ask the question is itself remarkable. It means that the universe has produced within itself a form capable of reflecting on its own existence. That, in itself, is a kind of miracle. As we reach the final part of our journey tonight, let us take a deep breath and reflect on where we've been. We began by asking a deceptively simple question: could consciousness exist without a brain? From there, we wandered through science, philosophy, and human wonder. We examined neurons and networks, quantum possibilities, and panpsychism, near-death experiences, and spiritual traditions. We explored identity, free will, ethics, and even the possibility that consciousness might pervade the cosmos itself. Each step revealed not certainty but depth, a recognition that this question does not have a final answer, and perhaps that is precisely why it matters. Now, as we close, let us bring this vast exploration down to the level of personal experience. You are listening right now, aware of my words, aware of your breath, aware of the subtle sensations in your body. That simple awareness is what we've been talking about all along. Regardless of whether consciousness arises from neurons or flows through the universe like an ocean, the fact that you are aware is undeniable. Awareness is the foundation of everything you experience, the silent witness of your life. This raises a profound point. Perhaps the more important question is not whether consciousness can exist without a brain, but how you relate to the consciousness you have right now. You might think of consciousness as a spotlight. Wherever it shines, that part of your experience becomes vivid. If you direct it outward, you perceive the world. If you direct it inward, you sense your thoughts and feelings. You cannot step outside of it because it is the very condition of experience. That makes it both ordinary and extraordinary, always present, yet endlessly mysterious. Science tells us that consciousness correlates with brain activity. This is true, and no one denies the importance of the brain. But correlation does not equal causation. Just because consciousness appears alongside neural processes does not mean it is fully explained by them. It may be that the brain acts more like a receiver or filter than a generator. This is a possibility we cannot dismiss, and it leaves room for wonder. Philosophy tells us that consciousness resists reduction. No matter how finely we analyze matter, we cannot find the subjective glow of experience hidden in its particles. This is the hard problem that David Chalmers described. Yet instead of despairing, we can view this as an invitation. Consciousness may not be a puzzle with a final solution, but a mystery meant to be lived. To live consciously is to embrace curiosity, to marvel at existence, and to participate fully in the unfolding of reality. Spiritual traditions tell us that consciousness is not limited. They describe it as eternal, universal, and deeply interconnected. Whether or not we interpret these claims literally, they point to an experience of expansion, a recognition that awareness transcends the small boundaries of the self. When we sit quietly, when we meditate or simply breathe, we may touch this expansion. We may sense that our awareness is not trapped, but open, vast, and connected to everything around us. And then there is the deeply human dimension. We long for meaning, we fear death. We wonder whether we continue after our bodies fall away. If consciousness requires a brain, then our awareness ends when we die. But if consciousness exists beyond the brain, then perhaps death is not the end. Perhaps it is a transition into a form of awareness we cannot yet comprehend. This thought has comforted people across cultures and centuries. It may never be proven scientifically, but its persistence reveals something essential about the human spirit. We are not content to see ourselves as mere machines. We sense something greater, and that sense itself is a form of evidence. Subjective, yes, but profoundly real. So where does this leave us? Perhaps with humility. Consciousness is the ground of our experience, yet we know so little about it. We can measure brain waves, map neural circuits, and analyze chemical transmitters. But the spark of awareness remains elusive. That spark is you, right now, listening. That spark is the dreamer who drifts into sleep, the thinker who contemplates infinity, the lover who feels joy, the mourner who feels loss. That spark is the essence of what it means to be alive. As we wind down, it feels natural to return to the theme of sleep. Each night, as you close your eyes, you undergo a remarkable transformation. Your waking consciousness dissolves, and yet awareness does not vanish entirely. In dreams, a new kind of consciousness emerges, strange, surreal, sometimes chaotic, sometimes profound. This nightly journey mirrors the larger mystery. If consciousness can persist in dreams without the same structure as waking thought, then perhaps it can persist in other forms as well. Sleep reminds us that awareness is not fixed. It shifts, adapts, and expresses itself in ways that defy our waking logic. And when you drift into deep sleep, something even more mysterious happens. Consciousness, as you normally know it, disappears. Hours pass in what seems like an instant. Yet from this blankness, you awaken again, awareness rekindled as if nothing happened. This cycle, waking, dreaming, deep sleep, offers a metaphor for existence itself. Awareness may contract, expand, and vanish from memory, but it remains the constant thread. Some traditions even suggest that deep, dreamless sleep is the purest form of consciousness. Awareness without content, like a still ocean beneath the waves. This is why sleep is such a profound reminder of the mystery we've explored tonight. Every time you drift off, you step into the unknown. You release control, surrender to darkness, and trust that you will awaken again. That act of surrender mirrors the greatest unknown of all, death. And just as sleep leads to awakening, perhaps death leads to a different kind of awakening. We cannot know for sure, but in the rhythm of sleep, we glimpse the possibility that consciousness continues beyond the forms we recognize. So as you listen now, allow yourself to feel the wonder of your own awareness. Feel how remarkable it is that you are here, that you can hear these words, that you can reflect on your existence. Let that awareness soften any fear of the unknown. Let it remind you that consciousness is not a problem to be solved, but a gift to be lived. Whether it arises from neurons, from universal fields, or from some mystery we cannot name, it is the source of your experience, and that makes it sacred in its own way. As we conclude, remember this: consciousness is the greatest mystery you will ever encounter, and it is also the most intimate. You do not need to solve it to be transformed by it. Simply noticing your awareness, appreciating its presence, can change the way you live. And when you lay down to rest, when you surrender to sleep, you can carry this sense of wonder with you. You can drift into dreams knowing that awareness is vast, flexible, and perhaps eternal. You can let go with trust, comforted by the thought that consciousness is not fragile but resilient, not small but expansive, not fleeting but profound. So tonight, as you prepare for sleep, take this journey with you. Let the mystery of consciousness cradle you as you rest. May you find peace in the knowing that you are part of something vast, whether within the brain or beyond it. May your awareness open to the beauty of existence, both in waking and in dreaming. And may you awaken tomorrow with fresh curiosity, ready to marvel once again at the gift of being conscious. Good night, and thank you for sharing this exploration.